solve the polynomial inequality x squared plus 12x greater than 7x. Now we could try to figure out where x squared plus 12 is greater than 7x, and that is actually possible. If I were to graph, x squared plus 12 is up 12, and it's an x squared graph. And 7x is slope 7, and there will be a spot where the parabola is above the line, but then after a while the line will be above, and then it's hard to tell though, but it looks like there's some kind of region in here where the line will be the parabola is above. Oh, it's everything else. It's hard to tell. So it's much easier to analyze this if we move everything to the left. Now we're looking for where is this parabola above the x-axis. Much easier analysis. Now if I factor this parabola, I have x and x. 4 times 3 is 12, and minus 4 and minus 3 is minus 7, greater than 0. So what we're looking at is a parabola that has x-intercepts at 3 and at 4. Furthermore, it's a positive x squared, so it opens up. So it's this kind of shape. And we want to know where is that thing above 0. So here it's above, and here it's below. Above is greater than 0. Below is less than 0. And at these x-intercepts is equal to 0. We want where is it above. So it's above everything to the left of 3, everything to the right of 4. So in interval notation, which is a convenient notation, negative infinity to 3, soft bracket union, soft bracket 4 to infinity. Now I can see this picture a little bit better as well. This is 3 and this is 4, and the parabola is above the line everywhere here, but then the line is above the parabola in between, and then the parabola catches up, and so it's this kind of shape, and that's 3 and that's 4. So we could analyze it with both, but this is definitely an easier analysis. The other thing people do, besides knowing that this is a quadratic function, a parabola, is that they actually test points. So a number line method, first off, I know 3 and 4 are not good because I don't have an equal sign here. So they're hollow dots. And then we would just test like 0 and 3.5 and like 10. 0 minus 4 is negative. 0 minus 3 is negative. 2 negatives make it positive. 3.5 would be negative and positive. That's a negative. 10 would be positive times a positive. That's a positive. Now notice I'm not really caring what I get. 0 would be negative 4 times negative 3. Technically, that's positive 12. But the positive is what's important because I'm looking for where is it greater than 0. So by just picking test values and plugging them in and determining if it's positive or negative, I can tell I want the greater than zeros, I want the positives. That's all of this stuff and all of this stuff. So you don't have to think of the graph, although it was really quick on this problem. You can also just do number line analysis by testing points to check the intervals. Either way, this is our answer to the solution of this polynomial inequality.